Well, good morning, everybody, and apologies for not being able to make it. I just want to quickly recognize the collaborating team here as part of this ultra early concept we came up with a few years ago. Uh, First, Graham Collier, our PhD student, who's done a great job of taking over the concept and then adding some of his own concepts to it, to where we've got quite a nice holistic system here. I co-supervised him with Dean Spanner. Rob Graff provided us with some early um, genotypes or germplasm we were looking at. And then now we have Kui Liu, who's pinch hitting for me today. So thanks, Kui. Bill Mee out of Indian Head, Chris Willenberg out of the University of Saskatchewan, Curtis Posniak and Rohan Yufang are collaborating breeders on this ultra early quad project. So what was the motivation behind this concept? It was a few things. One is the reality is we tended to just plant by arbitrary calendar dates, which really was driven by things like crop insurance deadlines over any sort of biological optimum for the crop itself. And really it was all inspired by a trip down to Montana where at the end of March there were guys down there prepping land. And so I thought, well, why can't we do that here? And so that was kind of the motivation behind all this, to sort of abandon calendar dates and come up with something prescriptive. And it goes without saying that we are experiencing climate change already. Probably the prairies are better off than most global regions of wheat producing areas. We could get more CO2. That's a good thing. But we probably have to start coming up with plans to mitigate the negativity things around abiotic stress. And all of this is like really leading to an opportunity where someone like Don Bowles out of Three Hills said, when I first started farming to where I just retired, I think I could seed 6 weeks earlier. So pretty compelling anecdotes there. And so our original proof of concept really was to understand what the risks would be if we went into ultra early as a concept. So using soil temperature as a driving trigger to start planting instead of an arbitrary calendar date. And then how does all that interplay with genetics and other cultural practices? So we took some lines that Rob Graff had. We used Stetler, our CWS, as a sort of a benchmark check. And then in the top 2 inches of the soil, starting at 0 in increments of 2 degrees, once we observed 0, we would plant if the soil allowed us to. And there was only one time where it didn't. And then sort of observed and measured what happened. And when you think about risk, it is kind of a scary proposition, because here we have Lethbridge. February 16th was when we observed 0 and the guys went out and planted. And that particular site had 36 days below 0 following that, as cold as -10, 23 weeks below -3. There were some serious frost effects, and you would think that this is going to be an absolute nightmare. But the reality is, when we start looking at things like the yield data coming off of this, our vertical Y axis here is yield. This CV here is a coefficient for variability. So we want to be as far to the left with the lowest possible variability in the field and as high as possible. So here's your green box. And really what you see here is a lot of 2s, 6s, and then what you see down here below, our worst performing ones was when we planted Stetler at 10, the very last seeding date, and it was also very variable. So, what that first experiment showed was that we've established a proof of concept where as soon as you can get in, once you observe 2 degrees, you're better off in terms of especially yield stability and quite often yield itself. The next thing we did was then start stacking on some other agronomic practices like seeding rate and seeding depth. And then went, again, the prescriptive practice. In this case, we dropped a few soil temperatures, but again, it was like, okay, as soon as it hits 0 in the range of 0 to 3, we go plant, or 5 or 7.5 or 10, again, in the top 2 inches of the soil. And here the guys are planting February 16th. And this whole interplay of G by E by M was really what we were at the heart of this study. The G being, do we need cold tolerant spring wheat lines? the practice of, the environment of cold soils, the practice of ultra early combined with sowing density and seed placement depths to give you that G by E by M paradigm. And so what happens basically if you waited, planting date 1 was as early as you could go in regions as far north as Edmonton. Basically, you started suffering a yield drag. And you never could compensate if you started off with a low planting density as well. So a low seeding rate rarely pays off. And here you see sort of part of it is because we're building up a really nice photosynthetic machine with those earlier seed dates. When you superimpose that over growing degree days, get to your peak radiation day, and it's things like planting date 1, 2, 3. The worst one though, planting date 4, which I would argue was a pretty common planting date, not just now but decades ago. And again, the seeding rate, you just never ever make your can compensate. This black one is the lower planting population, and it just never gets and compensates to where it can capture more radiation. And the implication of that is lower yield. So what have we learned? Interestingly, we didn't need co-tolerant lines. Just by virtue of the fact that we breed and adapt our current germplasm that's in commercial varieties in northern latitudes seems to be enough to resist the abiotic stress. Plus, we're combining that with a seed treatment, which we know we've published previously, will also lead to greater resistance to abiotic stress. No yield penalty for seeding at 2 degrees, and that sweet spot is like sort of in the 2 to 6 degrees, but anything beyond that, you start observing a yield drag. And really, when you start combining ultra early seeding with a more traditional practice of, May 10th was the deadline for crop insurance, but even if you say May 1st, when average soil temperatures is over 10, you could literally be losing $200 a hectare. And that we published. Graham did a good job of pulling all that together and publishing that. And then he went on, these are some of Graham's own concepts. We just looked at CWRS. What are some of the other market classes and how do they respond? And basically it was just a similar story. And in this case here, the green circles are all the early planted ones, giving us either similar yield and higher yield stability, or both higher yield and high yield stability. So a good story there. Another good sort of story here is obviously you can't use a pre-seed burn down with going out in February. There's no point. But Graham, and particularly with his background with New Farm, he looked at going with a soil residual herbicide instead, like a pyroxasulfone or a flumioxazin, and that actually gave us some really good results. Just note though that you can only use flumioxazin with durum. You cannot use pyroxasulfone. It's a little bit sensitive to that. So Volterra just for durum, but you can go with Fierce or pyroxasulfone alone for all the other classes. Really good story there. Takes a little bit of planning, but it's a really highly compatible strategy with ultra early seeding. So what are some other future directions we're looking at? Well, we've actually looked at disc opener versus hole opener, slight advantage to a hole opener, advantages to going a little bit shallower, we feel. And then the big question is, well, what about durum? And thankfully, Sask Wheat funded a project for us to explore what we get from durum. And so here are the guys going out again, planting starting at 0. And in this case, the earliest ever was last year, where we planted on February 9th. And here's the results of that. We had 5 cultivars. And really, here's a great figure here of the implications of planting late. And so sometimes 0 isn't that great, but definitely the sweetest spot you can be is if you can get in there starting at 2 degrees in the top 2 inches, and then things just trail off after that. CDC Defy seemed to be higher yielding and somewhat maybe better adapted. We don't know. We don't have enough. This is only based on 5 locations so far, so we don't know for sure. Again, we took and applied this to sort of a systems approach now. We're comparing now 3 varieties to planting depth of 1 inch versus 3 inches. And we're also looking at dormant seeding because that's a big question there. We have Kent Sarit out in Rolling Hills planting an entire quarter section. But the prescriptive thing here, though, is if we're going to say we're going to be dormant seeding, we have to wait until that soil cools down to below 2 degrees. Otherwise, we're in big trouble. And we risk that seed sprouting and causing problems. And that, in terms of like just dying off. And so when the guys went out and planted our first ultra early at 0, they dug up some of the dormant seeded stuff we planted in November, and sure enough, some had popped a little bit. So we thought it would be just a total write-off. But look at the nice conditions we had at Rolling Hills. Our conditions were great. Kui got in there a week later, some really nice planting conditions in Swift Current. So it is possible on the prairies, especially the southern prairies, to do dormant planting. But what are the implications on yield? Well, here you go. We've got dormant seeding here where it didn't work out quite as nice. This is the dormant seeding one here, DS. Somewhat similar to if you really waited until 10 degrees and planted. But again, the top one, though, is that sweet spot of, basically anything beyond 0 degrees gives you the top yielding environment once again. So what about adoption and scale up? Well, here's some of the early ones. Jay Schultz phoned me back in the day asking about it when we first got going on it and wondering about it. And I was like, well, I told him the prescriptive practice to get out there. He's reading 2 degrees. I said, yeah, go plant. And then all of a sudden it was that year where we had frost events that were as cold as -11 when these seedlings are already up out of the ground. And I thought it was going to be an absolute train wreck, but it turned out to be one of his best crops ever. Matt Gold out of Central Alberta practicing it now and really a firm believer in it. Saskatchewan, Weyburn, same story there. Best looking field around. And so really there's a lot of benefits to it. We showed you the photosynthetic machine that you can build and build better by going earlier, because you are capturing more growing degree days and more solar radiation. That gives you a highly competitive crop. Earlier, potentially longer grain filling. You're avoiding some pest and disease cycles. You can distribute your farm labor better as well as your capital costs. And yeah, it's same or better yield, definitely better yield stability, and probably more cash in your pocket. A lot of what you would see in a winter wheat system, basically. And so the risk would be you got to watch your field conditions. We're not saying that you can plant every year in every location, but certainly we're surprised at how consistently you can plant and do this practice compared to when you can't. So hopefully that was somewhat clear. If you have any questions, I'm sure Kui would be happy to try and take a stab at it. And big thanks to our collaborators and funders on this project. And a shout out to ZZ Wang for preparing some of the figs and tables and Graham Collier, of course, our PhD student who did a lot of work for this up at the University of Alberta. So thanks a lot.